So again, this is the Chapter 2 review. You guys can see what I've assigned here. It's 2, 4, 6, 8, and so forth, all the way to number 20. That's what I want you guys to do. So let's look at these here really quick. So number 1, for example, you don't have to do number 1, but I'm just going to use that as an example. If you're multiplying fractions together, 5 over 7. In this case, we can't do any cross-canceling either way, so you're just going to end up multiplying straight across. 1 times 5 is 5. What's 8 times 7? Of course, if you don't know, you could look. Yeah, Mr. Lesueur? 56. Okay. 5 is prime, so this cannot be reduced, so that would be the answer. All right. Of course, you don't have to do number 1, but I'm just kind of reminding you how to multiply fractions together.
Can you show us one? Can you do a little bit of review on the cross-canceling?
Yeah, I sure can. What I'll do here is, let's look at number 8 for a moment. So we have 2 3/10 times 5 1/3. So you have two mixed numbers, and so we need to change both of those into fractions so we can multiply them together. And as a reminder, it would be 2 times 10, which is 20, plus 3 is 23 over 10. Remember, the denominator stays the same. Times 3 times 5 is 15, plus 1 is 16. That's going to be 16 over 3. Okay? And again, remember that the denominator stays the same. Can we do any cross-canceling? Yeah, we certainly can. I'm looking at, let's say, 10 and 16, for example. Is there a number that will go into both 10 and 16 evenly? Yeah, Miss Werner has her hand up. It's 2. 2 goes into 10, how many times? 5. 2 goes into 16, how many times? That would be 8. The other 2 that we could possibly cross-cancel would be 23 and 3, but 3 does not go into 23 evenly. So what do we have here? It would be 23 over 5 times 8 over 3. And you just multiply straight across. So that's number 8, somewhat set up for you. I won't take it any further. I'll let you guys do the rest. Let's move down. Then it looks like divide and write the answer in simplest form. That means you need to reduce. So I'm going to look at number 11, even though you don't have to do number 11. Here's an example on how you would do 10 and 12. So we have 5 being divided by 1/3. What do I need to do with that 5 before I can do anything else? Mr. Patania. Miss Scott, what do I need to do with that 5 before I can do anything else?
Put a 1 under.
Yeah, I need to change it into a fraction, so it's 5 over 1 being divided by 1/3. Okay, nicely done. Put up 20 points. My next question, Mr. McGee's not here. Mr. Williams isn't here. Mr. Conyers, what's the next step I would do in this problem?
Keep, change, flip.
Keep, nicely done. Put up 30 points. Keep, change, and flip. So you keep the first part of the problem the same. You change it from division to multiplication, and then you flip the last part. So I could rewrite this as 5 over 1 times, because remember, we're going to change it from division to multiplication, and then I flip it to 3 over 1. And now I'm simply going to just multiply straight across, because I can't do any cross-canceling. It's going to be 15 over 1, which is the same as what? 15. Remember, any number under or over 1 is basically itself. So the answer to number 11 would be 15. What's that?
Does that mean that if you have one underneath both numbers, you don't even have to write it as a fraction? You could just do 3 times 15?
Right, and if somebody didn't do the 15 over 1 and then they just wrote equals 15, I would have been fine with that. So if somebody had just written as the answer 15, that's fine. Okay. Other questions? Because remember it says write the answer in simplest form.
15 is simplest form.
Right, 15 is the simplest form. So that's an example on how to do number 11. Of course, you don't have to do number 11, but you would do 10 and 12 very similarly. All right, let's move down. Next page. Again, you're doing the even numbers, so it would be 14 and 16. So again, you have now mixed numbers, and you need to change those into fractions. And then after you change them into fractions, you need to do the keep, change, flip, and then see if you can do any cross canceling. So 14 and 16. And then 18 and 20. It says add or subtract. So for the 18 and 20 down here, you're dealing with decimals. And you should remember that when you add or subtract decimals, you line up the decimals. Okay? Questions, you guys? Yeah.
Can you do either an adding or subtracting, like decimal problem as an example?
Sure can, honey. Pick one, 19 or 20. Which one do you think would be more helpful to you? 19? Okay, so I'm going to add these two decimals together. So I'm going to, when you're adding or subtracting decimals, it's really important to keep things lined up. So it's 19.89. And I'm adding to that 4.372. So I'm going to hit a little plus sign, and I'm going to put the 4 right under the ones place, right under the 9, because that's what they both are, the ones place. So it's 4 point, and then 3 under the 8, 7 under the 9, and then a 2. And I'm going to put a 0 there just to kind of help me keep things lined up. And then you would just simply add those numbers together. So when you add or subtract decimals, you always line up the decimals. So let me give you one more example since somebody asked about it. Let's say I had 426.1, and I'm adding 0.00527. Well, again, you just got to keep the decimals lined up. So it would look like this, 426.1, and then I'm going to put 0.00527. And I could put zeros here to kind of help me keep things lined up. Okay? Yeah.
And when you're subtracting, that you always put the biggest number on the top.
That's right. When you're subtracting, you always put the larger number on top. And that is the case for you guys. That's going to change 7th grade because you're going to be dealing with a lot of negative numbers. And actually, I haven't looked ahead in your book. I don't remember if you guys deal with negative numbers much. But as a rule of thumb, Mr. Conyers, that's exactly right. You would just put the larger number on top.
Okay.
Do you just drop the decimal?
What, honey?
Do you just drop the decimal?
What do you mean?
Like, do you drop the decimal?
Oh, and that example that I gave?
Yeah.
Yes, you would just put the decimal then straight down and then go ahead and do the math. Okay. And whether you're adding or subtracting, the decimal would just go straight down. Okay? Yeah.
We do.
What, honey?
We do deal with negative numbers in the book.
You do? Okay. Well, cool. Negative numbers are a lot of fun.
Cool.
So, and I'll throw those in the mental math too.
Really?
Yeah.
Cool. I'm not sure.
Yeah. No, negative numbers are awesome. You guys
That's easy.
will like it.
Yeah. Adding them is easy.
Because once you get into negative numbers, then we can start doing some more graphing, and it's so cool.
Like minus 1
I have to
or
say, I'm
Okay, so let me, just to be perfectly clear, I want you guys to do, so it'd be 2, 4, 6, 8. It'd be 10, 12.
14, 16,
Yep, I heard somebody say it, 14, 16, 18, and 20. Okay, and of course I have that
right here.
written down right there for you.
Nothing in the multiplying and dividing decimals?
We'll get to that tomorrow. Okay, so that's all you guys have to do.
And that's our homework?
Homework or classwork, actually, it shouldn't take you too terribly long.